Alright, till now we have learned two different types of linked lists, which are single linked list and circular single linked list. So in this video we will start to learn another type of linked list, which is double linked list. Okay, let's recap what's the difference between double linked list and single linked list. In the case of single linked list, each node refers to the next node. As you can see from this sample that node 1 refers to node 2, node 2 refers to node 3, and node 3 refers to node 4. But there is no way that any node can point back to the previous node. So if you want to traverse from node 3 to node 2, that it's not possible in case of single linked list. This is limitation of single linked list, because here the reverse traversal is not possible. To overcome this problem, we have a double linked list. In the double linked list, each node contains two references that references to previous and next node. This allows us to traverse forward and to traverse backward, which means that we can easily come back from node 3 to node 2 and from node 2 to the node 3. So in both ways, traversal is possible. Now let's see how can we create a double linked list. The first thing that we are going to do here, we need to create head and tail references, and then we will create blank node. Then after creating a blank node in the memory, we assign a value to this node. Let's say the value of this node is 5. Since it's the only node in the list, the previous and next references will be the null. So then we need to connect head and tail to this node. So we know that the physical address of this node in the memory is 111, so we will set head reference to 111. So by setting this to 111, it creates a link between head and this node over here. Then the next step is we need to create a link between tail and this node. Once again, we will update tail references with the physical location of this node, which is 111. So by updating tail, we are creating connection between tail and this node over here. So if we put all these steps together, we can create an algorithm of double linked list creation. So the algorithm starts from here. It takes node value as a parameter. Then in the next step, we are creating blank node. Then after creating blank node, we are assigning value to this blank node. And this value comes from the parameter over here. Then the next step is we are setting next and previous references of this node to null. So after setting these references to null, we need to create a link between head to this node and tail to this node. So in the next step, we are setting head to this node and tail to this node. Then after doing this step, we terminate our algorithm. So the creation of double linked list is completed. Now let's switch to Visual Studio Code and create double linked list in practice. Okay, now here we will create our node class and double linked list class. I removed the node class that we created before because in case of double linked list, the node class is different. So here, the first thing that I'm going to do, I will create node class. Class node. So inside this class, we have, as always, init function. The self is default parameter here, and it takes value. So by default, value is none. Then we know that in our node, we should have three variables. The first one will be the value of this node. Then self value, we are setting the value to the value that comes from the parameter. Then the next property of our node is next reference. So then we set it to none. Then we should have previous reference for this node. So I will create previous reference over here, and which will be set to none also. So after creating our node class, I will create our double linked list class. Here, I will create class doubly linked list. Then inside this class, we will have again init function. So by default, self is a parameter. So we know that in our double linked list, we should have head and tail. So I will create head here, which will be set none. And the next property is tail, and this will be set to none. So with this, our double linked list and node class is completed. So here inside double linked list class, we will create our methods. But before creating our methods, I want to add an extra method over here, so which makes it easier to print out our double linked list. So by printing out our double linked list, the operations that we will perform on our double linked list can be seen easily. So that's why I put a default method over here, so which helps us to print out our method. So it will be iter like this. Then node starts from the self dot head, and while node yield node, and node equals to node next. So this function helps us to print out our double linked list. Now here, under this function, I will create the function that we want to create in this lecture, which is creation of double linked list. So I'll comment here creation of double linked list, linked list. Then here I will create our method. So our method will be create double linked list. This method by default takes self as a parameter, and as we said in our algorithm, it takes node value. So the first step in our algorithm is to create a node and assign a value to it. So I will create node over here, and based on the node class that we created. So here I will set the value of node, the value that comes from the parameter. So with this, we created our node. So the next step is we need to set next and previous references to node. So node.previous equals to none, and node.next will be none. Then we need to create a connection between head and this node and tail and this node. So we will set self.head equals to node and self.tail node. So after finishing this, I will just return saying that the double linked list is created successfully. So with this, our creation of double linked list method is complete. Now let's see how this is working in practice. So here I will create double linked list based on the double linked list class. Then I will call this create method, which will take the value of 5. So after running this method, let's print out our double linked list. As we said before, we will print out from here. So let's run our code. You see that our double linked list is created with one element, which has the value of 5. So as you see, our method works correctly. Now you might be interested what is the time and space complexity for this method over here. As always, we will start from the first line. So in the first line, we are creating a node and assigning value to it. And this takes O1 time complexity because this is not time consuming operation. Then in the next line, we are setting previous references to none. This is also O1 time complexity. And then we are setting next reference to none. And this is also O1 time complexity. Then setting head and tail to this node also O1 time complexity. At the end, we are just returning default text message over here. This is also O1 time complexity. So if we combine all these complexities over here, we are getting O1 time complexity, which means that creation of double linked list takes O1 time complexity. Now you might be interested what is the space complexity for this method over here. The space complexity is also O1 because in this case, we are just creating one node over here. So it does not take much space in the memory, which means that this is O1 time complexity. So this is all for this lecture. So in this lecture, we have discussed how can we create double linked list, and we have learned an algorithm of creation of double linked list, and we have created it in practice. And we saw what is the time and space complexity for this operation over here. Now in the next lecture, let's learn how can we insert an element in double linked list. See you there.